Is this slide visible to you guys? Okay. So today we are going to discuss the chapter that is named Force and Motion. Force and motion. So we all know what force is. Force is an external agent. Force is what? Force is an external agent that changes the state of motion of an object. Force is an external thing that changes the motion or state of motion of an object. For example, if an object is at a stationary position, for example, a object is at a stationary position like this, and if we apply a force on it, let's say it has a velocity 0, if we apply a force on it, it starts moving. It gains some velocity. It gains some velocity. Or let's say an object is moving with some velocity. If we apply a force on it, it's gonna move. It's gonna move fast. It's gonna move fast. Okay. Or for example, an object is moving fast in this direction, and if you apply a force on it in an opposite direction, then it's gonna slow down. It's gonna slow down, or it's gonna stop. So force is the external is the agent that can change the motion state of motion of an object. So আমরা সবাই জানি, we all know this. So today in this chapter, what we are going to doing, we are going to discuss the different laws, basically the Newton's laws of motion and some of the mathematical problems that are relating to it. So all the object, we say all the object, basically there's the big object, all the big object uh, uh, follow Newton's law of motion. When all the big objects, when they are moving, they follow Newton's laws of motion, and Newton gives 3 laws, and these are very well known to you guys, but let me reiterate it once again for you guys. For example, the first law saying that if no force is applying on an object, then its state of motion is not going to change. Force যদি apply না করো তাহলে its motion, state of motion is not going to change. What does this mean? This means if an object is at stationary motion, it will remain stationary, or if an object is moving, its velocity is remain constant. Okay, so stationary object will remain stationary, and moving object will move at a constant speed or at the same speed. Okay, this is the first law. Basically, the main law of Newton is second law. First law is kind of modification of the second law. Yeah, this is the first law. I'm sure it's done, I guess. And the second law, this is the main law of Newton's Newton's main law, basic law, যেটা বলবো of motion, and all the other 2 laws are like kind of like modification of these things. So it says the force on an object is equal to the net force on an object is equal to the product of the mass of the object and its acceleration. The net force is equal to mass times acceleration. So this is the Newton's second law. This is Newton's second law, and this is a very important law. Okay, so actually we can write F net equal to ma. So what is F net, by the way? What is F net? F net means net force, total force, and see here it is a vector. A vector sign is there. That means F net means sum of all the forces acting on an object. For example, an object is this is an object, and maybe 1 or 2 forces are acting on it. Maybe this is a force F1, and the force F2 is acting on it, and the force F3 that is acting on it, and then and the force F4, this may be acting on it. So the 4 forces are acting on it. So net force F net is basically equal to the vector sum of all the forces, that is F1 plus F2 plus F3 plus F4 for this case. Okay, sum of all the forces. So that means ma is equal to sum of all the forces acting on the particle. Is the thing. And now the other thing is, oftentimes or most of the time we work with 2 or 3 dimensional system. Basically, space is 3 dimensional. Space is 3 dimensional, right? X-axis, y-axis, and 3 axis are the 3 dimension. So our space is 3 dimension. So our space is 3 dimensional space. So we can write this equation. Write this equation, the second law. We can write the second law for 3-dimensional system. When we write it for 3-dimensional system, we can separate the axis. We can separate the component actually. So that means we can write m component of a equal to ax equal to f net x. Okay, this is the x component of the net force, or I can say may equal to f of net y. This is the y component of net force, and maz equal to F net of Z. That means when we are dealing with 2 or 3-dimensional system, in that case, we have to consider each axis separately, okay? Each of them separately, like x direction, y direction, and z direction, okay? So this is basically the second law of motion. And basically, when we are dealing with a problem like this, like more than one force is acting on a particle, in this case in particular, it will be useful to deal with the problem. Like again, I'm saying when we are dealing with a system in which more than one force are acting on an object, and not only that, the object is moving in a 2-dimensional space, in that case, it is always better to draw a free body diagram of the object to solve the problem. Free body diagram is like, for example, like same problem. For example, this is an object. How to draw a free body diagram? Let's say this is an object. Okay, and on this object, 2 or 3 forces are acting on it. F1 is one force. F2 maybe is another. F2 is another force that is acting on it. F2 is another force acting on it. And then maybe F3 is another force that is acting on it, right? And let's say F4 is another force acting on it. And another force, maybe let's say F5 is another force acting on it. So when we draw the free body diagram, we are gonna consider this object as a dot. Okay, we are gonna consider this object as a dot. Okay. This is a dot. This dot, I'll consider this as a dot. And then what I'll be doing, I will consider all the forces separately. I'll consider all the forces separately in the sense that at first I'll consider the force that are acting along x direction, and then I'll consider force that are acting along y direction. Okay, so this is how I'll draw the free body diagram. Now for x direction forces, how many forces are acting on x direction? F1, F3, and F4. These are acting along x direction. So F1 is acting along this way, right? Positive x direction. Let's say this is my x direction, positive x, and this is my positive y, right? And this is my negative x, and this is my negative y. So this F1 is acting along positive x direction. So this F1 is acting along positive x direction. This is my F1, okay? And then my F3, it is also acting along positive x direction. So it is F3, and F5 is acting along negative y direction, okay? So this is the free body diagram of this object for x. This is the free body diagram for the x component of forces. Same again for y component of forces. We will see, okay, this is the object, and F3 is acting along positive y direction. This is my F3, and this is my F4. So this is how we can draw the free body diagram, and this is the y component. Okay. And a free body diagram is a easier way to solve the force related problem. Okay, so we're going to take help of this kind of diagram when we will be solving the mathematical problem. And now again, in any object, in any case, 2 kinds of forces may act on an object. At the object report, 2 or 3 types of force can act. Okay, one is called external force, the other one is called internal force. For example, this is a box, and you are pulling it. Let's say this is your hand. With hand, you are pulling it like this way, F1, and this way someone is kicking it, right, toward this way. So this, all of them are external force. These are external force, and the state of motion of an object it changes due to the external force. Okay, external forces jonno objecter motion change kore. Yeah, and there exists another force that is called internal force. Actually, internal force are the forces that are inside the system. For example, the object consists of so many molecule or atom or something like this. So these are also applying some force on each other, something like this. Okay, they do some interaction. But for external force, for internal force, actually they did not take part in the motion of the object. A internal force gulo object motion take part kore na, basically because they actually cancel each other and they did not take part into the motion of an object. That is why when we are dealing with Newton's law, we are not going to consider internal force. We'll be considering external force only. Okay. So that's it basically about the first and second law. And what we will be doing now, we will be using this kind of free body diagram and Newton's second law to solve some mathematical problem. So here is the problem, but this is basically a checkpoint. This is saying that 2 horizontal force, 3 Newton and 5 Newton, are acting on an object on a frictionless floor. These 2 forces are acting on this object that is on a frictionless force, and then it is asking us if a third horizontal force F3 acts on the block. If another force, that is F3, acts on the block, what are the magnitude and direction of F3 when the block has stationary and moving left with a constant speed of 5 meters per second? So 2 things. This is an object. 2 forces are already acting on it. One is 3 Newton and the one is 5 Newton. Okay. And now they're asking us, if I want to apply another third force, what should be the magnitude and direction of this force so that the object will be stationary? That means object will be stationary, object move korbe na. Koto Newton force apply korle? Or what should be my F3? This is like, a force is like this, and 2 forces are acting on it. One is 5 Newton. Let's say this is F1, and the force F2 is acting on it, that is 3 Newton. And now you have the option to apply another force F3 on it. And what should be the magnitude and direction of this force F3 so that this object remains stationary? So let's say F3 is this way. F3 is this way. Okay, this is my force F3, and I have to apply. I have to apply second law to find the value of F3. So Newton's second law told us MA equal to F total. Okay, not F total, I can say F net. MA equal to F net. And here, by the way, all the object is moving along which direction? Protected object, কোন direction move করছে? They are moving along x direction. Let's say if this is x direction, so this is my x direction. So that means MAX equal to F net x. Now see here, F1 is equal to what? 5 Newton. F2 equal to what? 3 Newton. And F3, I don't know what it is. F1, so this is my like F1 plus F3 minus F2. Can you tell me why I write F2 as why I give a minus sign to F2? I give a minus sign to F2 because it is acting along negative of x direction. Okay, a direction negative. I'm considering positive x as I'm considering positive direction of x as positive. Sir. Okay, so now F max, and since the object is stationary means what? If your object is stationary, that means my acceleration is 0. Stationary means my acceleration is 0. That means I can write 0 equal to F1. F1 is 5 plus F3 minus 3. So that means F3 plus 2 equal to 0, or F3 equal to minus 2. See here, the value of F2 is minus 2. What does this mean? What does minus means? বলতে পারো?
Sir, opposite direction.
This means that actually we consider that F3 is acting along positive x direction. Basically, no, it would be act as negative of x direction. So this means F3 is negative 2 Newton. So that means F3 is acting along negative of x-axis direction. So this is my part A, and my part B is like it is moving left with a constant speed of 5 meters per second. It is moving left this way. Acceleration is along this way, okay, is equal to 5 meters per second. So in this case, again, I can apply this formula. MAX equal to F1 plus F3 minus F2. And now M is what? M is given, right? What is the value of M? Okay, let's say M is M. M is not given here. Let's say M is M. And AX is what? 5. meter per second square, and it is acting toward the negative direction. So max equal to -5 equal to f1 is 5 plus f3 minus 3. Okay, so that means my f3 will be equal to -5m and -2. That is equal to -5m plus 2. Okay, so this should be the value of f3. Again, in this case, mass is not given here. In this case, once again, f3 would act along negative of x direction. Negative of x direction. And I have to put the value of m here. So this is the math. Is it clear to you guys? So we're going to do some more math. This kind of some more math. Okay. So let's try the first one. Here is another sample math. Here is an example to show how to use Newton's second law for a puck. Puck means like is a dice that can travel along one direction. Like আমরা ক্যারাম খেলি, ক্যারামের যে স্ট্রাইক বা গুটিগুলো আছে সেগুলোর মতো, that is called puck. When one or two forces are acting on it, part A, part B, and part C shows three situations. In figure 5.3 shows three situations, right now, in which one or two forces act on a puck that moves over a frictionless ice along the x direction. So see here, a clue is given here. The object is moving only along x direction. That is one-dimensional motion, and the puck has mass of 0.2 kg, and F1 or F2 are two forces. See here, two situations. F1 and F2 are two forces directing along their axis. F1 is along positive x direction, F2 is negative x direction. F1 equal to 4, F2 equal to 2. Now force F3 is directed at an angle of theta equal to 30 degree. Force F3 is acting at an angle of 30 degree and has the magnitude of F3 equal to 1 meter. Situation 3 তে দেখো F3 কাজ করছে, situation 3 তে F3. So in A situation, what is the acceleration of the puck? তিনটা situation আছে দেখো. In first situation, only one force is acting on it, that is 4 Newton. In second situation, two forces are acting on it. One is 4 Newton and the other is 2 Newton. And in the third situation, a third force F3 and a force F2 are acting on it. Okay, I have to find out what the acceleration for each of the three cases. So let's try this math. This is really very easy math. I know you guys already. It is you guys will find it very easy. Okay. So let's try with start with situation A. No, this is situation C. So let's start with situation A first. For situation A, we know F equal to ma, and like net force, I don't actually need to write net force because only one force is acting on it, and all the forces are acting along x direction. I can say like Fx equal to max. So my m is what? Let's see, what is it? M is 0.2 kg, 0.2 kg, and F equal to 4. So my F1 equal to 4 Newton. So 4 equal to mass which is 0.2 times acceleration. That means my acceleration equal to 4 over 0.2. That is 20 meter per second square. This is part A. And part B, I have two forces here. You see, one force is acting along positive x direction. The second one is along negative x direction. So if I consider plus x means positive, positive means plus x, tahale F1 is positive, F2 is negative. So now my formula is F net equal to F net x equal to max. So F net is what? F1 plus F2 equal to max. My F1 is 4, F2 is 2, and it is acting on negative x direction, so -2 equal to m is 0.2 into ax. So this gives us ax equal to 2 over 0.2, that is equal to 10 meter per second square. This is part B. And in part C, you see two forces are acting on it. One is along this x direction, and another one is along, another one is making 30 degree theta. That means 30 degree with the negative of with the x-axis. So if I plot a free body diagram for it, one force is F2 that is acting along this way. This is my x direction, and F1 is acting this way, and this is making an angle theta equal to 30 degree with x-axis. 30 degree. So what is the angle that f3 makes with positive of x-axis? Positive x-axis এর সাথে f3 কোন অ্যাঙ্গেলটা প্রডিউস করে বলো তো একটু? পজিটিভ x এর সাথে কোন অ্যাঙ্গেলটা প্রডিউস করে? যে দেখো x এর সাথে কিন্তু নেগেটিভ x এর সাথে সে কিন্তু অপোজিট দিকে মুভ করছে। এখানে থিটা ইকুয়াল টু 30 যদিও আমরা বলছি বেসিক্যালি দিস থিটা ইকুয়াল টু মাইনাস অফ 30, দিস থিটা ইকুয়াল টু মাইনাস অফ 30, কারণ 30 আমরা কোভাবে মেজার করি অ্যাঙ্গেল, উই মেজার কাউন্টার ক্লকওয়াইজ। সো এই দিক দিয়ে আমরা মেজার করতে হবে। ওকে, সো হিয়ার 30 মিন্স মাইনাস 30, 30 মিন্স মাইনাস 30। তাহলে নেট ফোর্স এফ নেট ইকুয়াল টু এম অথবা এফ নেট অফ এক্স, কারণ আমি এক্স ডিরেকশনে মুভ করা অবজেক্টটা এম এ এক্স। তাহলে এক্স কম্পোনেন্ট অফ এফ টু ইজ হোয়াট? এক্স কম্পোনেন্ট অফ এফ টু ইজ মাইনাস এফ টু, and then plus component of this is f3 cosine of minus 30 equal to max. Is it clear to you guys? এটা কি ক্লিয়ার তোমাদের কাছে? একটু বলতে হবে আমাকে ভাই। হ্যালো?
Yes, sir.
Okay, so that means my f2 is minus 2 plus f3 means 1, and cos minus 30 means minus cos minus 30 means cos হচ্ছে plus 1 to 1 into cos 30 equal to 0.2 into ax. Can you complete the sum for me, please? And tell me the answer. Something complete করতে পারবা? X equal to what? Anyway, I left it for you guys. You have to try it. I left it for you guys, so do it at home. Yeah. Let's try a more another math. So here is the math. So it is saying that F1 is an object. F1 is an object having mass 2 kg. F1 is an object that has mass 2 kg, and this is overhead view of the object. Okay, so two forces are acting on it. One force is F1, that is, sorry, F1 equal to 2 Newton, 20 Newton. It has an acceleration that is 12 meter per second, and theta equal to 30 degree. So here theta equal to 30 degree. That means it makes 30 degree with the y-axis, negative of y-axis. Find the second force in a unit vector notation as a magnitude and angle relative to the positive direction of x-axis. তোমাকে এটা একটা অবজেক্ট, এটার উপর দুটো ফোর্স কাজ করে। One is F1, the another one should be F2. I don't know what the F2 is, maybe this way or other way, I don't know, or এদিকেও হতে পারে। So আমাকে প্রথমে বলতে হবে the value of F2 in unit vector notation. That means ij use করে বলতে হবে F2, and the second thing is I have to find out the magnitude and angle that it makes with F2 makes with the positive of x-axis. Positive of x-axis of the angle প্রডিউস করে। এখন look here, this is a two-dimensional scenario. This is a two-dimensional scenario. So let's say আমাকে তো F2 বলতে হবে in unit vector notation. আচ্ছা, প্রবলেমটা কি বুঝতে পেরেছি আমরা? না বুঝলে আমাকে একটু বলো। Okay, so now let's say F2 is in unit vector notation. I can say like F2 means F2xi plus F2ij. Okay, so this is my F2. এটা আমি ধরে নিলাম I have to find out F2x and F2y, and this is F2, and I have to find out F2 in unit vector notation. Now if you just have a look at here, এখানে দেখো, and let's draw a free body diagram for this object. Free body diagram for this object. It has a F1 along this way. Okay, and acceleration, this is acting along this way. Acceleration. So this is my x-axis. This is my x-axis. Sorry, this is my y-axis, by the way. This is the y-axis, and this is the x direction. So what is F1, by the way? F1 equal to key. F1 has a magnitude of 20. So F1 equal to আমি বলতে পারি F1 xi plus F2 xj. sorry, f1 xi plus f1 yz. This is f1. So what is the x component of f1? f1x equal to koto? f1x means f1 cosine of the angle it makes with x-axis. With x-axis, it makes an angle of 0 degree. So cos 0 equal to 1, and f1, magnitude of f1 is 20. So it is equal to 20, right? Same here, f1y equal to f1, and then the cosine of the angle that it makes with the y-axis. It makes an angle of 90 degree with the y-axis, or you can write sine 0, same thing. That is 20 into 0, cos 90 means 0, that is equal to 0. So f1x means actually 20 I, this is my f1 in unit vector notation, and my acceleration. My acceleration also has two components. Acceleration also has two components. Acceleration has two components. One is acceleration is, see here, acceleration. This is my acceleration. It makes an angle 30 degree with y-axis. So what? So that means it makes an angle. What is this angle? What is this angle? The red color. 180 plus this one is 60, 240. So it makes 240 degree. It makes 240 degree with the positive of x-axis. Acceleration. It makes 240 degree. So acceleration has two components again. One is a1, ax. X component of my acceleration is a cos 240. Okay, because 240 is the angle that it makes with the x-axis. A cos 240 equal to what? একটু বলবে আমাকে a is 12. What is the value of cos 240? Calculator আছে কারোর কাছে? নাই? Okay, let me do it by myself. 12
Minus half.
cos 240 means minus half, তাই না?
Yes, sir.
Minus half, that is equal to minus 6. So x equal to minus 6, and again a y is a y component of acceleration, that is the angle that it makes with y-axis. Y-axis এর সাথে কত অ্যাঙ্গেল তৈরি করে দেখো, this is 90 and then 60, 150. That should be a cosine of 150. So a is 12. Cos 150 means what? 150.
150 হচ্ছে স্যার minus root 3/2.
I to multiply করে বলো ভ্যালুটা কত? It should be 8.39 or something like this. 8.4 maybe, I guess, right?
Minus 6 root over 3. Minus 10.39 answer.
10.4. Okay, minus 10.4. Okay, minus 10.4. So this is my ay. এখন এই জিনিসগুলো আমি করলাম, এটা আমার সময় কাজে লাগবে. Let's see. Our second law is what? Newton's second law. Second law is tell me that f equal to f net equal to ma, or here my f net is what? F net means f1 plus f2, right? I have two forces here, f1 plus f2 equal to ma. And now let's take the x component. X component. Let's consider the x component. The x component of this equation is f1x plus f2x equal to max, right? Max. So my f1x is what? F1x is 20 plus f2x equal to m is what? Mass of the object is 2 times ax. Ax is equal to minus 6. That means f2x is equal to minus 12 minus 20. So f2x is basically equal to 32. Okay, this is my, oh, minus 32 by the way. It should be minus of 32. Okay, this is my f2x. And same again, y component. Let's consider the y component now. Y component. If we consider the y component, this gives us f1y plus f2y equal to may. By the way, f1y is equal to 0. So I just left with f2y. This is equal to m is 2 and AY is minus 10.4. So that means my F2Y is equal to minus 20.8. So this is my F2Y, okay? This is my F2Y. So as I have now F1, F2X and F2Y, by substituting these two here, by substituting the value of F2X and F2Y here, I can write it in a unit vector notation. So my F2X is now, so my F2 is equal to F2XI plus F2YZ, or this is means minus 32, right? 32I minus 20.8J. So this is what they were asking for. This is the vector F2 in unit vector notation, okay? And then in part B and C, they were asking for the magnitude and angle that it makes with positive of x direction, okay? Angle it makes with positive of x direction, সেটা আমাকে বলতে বলছে, and magnitude বের করতে বলছে of F2. So whatever. So and once I know the F2 in unit vector notation, it is very easy for me to find the magnitude in unit vector notation. It is just very simple. We know minus 32 whole square plus minus 20.8 whole square. So I left this calculation for you guys. Okay, so once you do the calculation, you will find the value of F2. And now FC, they are asking me for the direction that F2 makes with the positive x-axis. F2 the direction, F2 positive x এর সাথে কোন angle produce করে. So we know if this is my vector A, if it makes an angle theta with x direction, we can write tan of theta equal to tan inverse y component divided by x component. একটু মিউট করবা না কেউ? মিউট করে দিত। Okay, thank you. Okay. Okay. So now this is the formula, tan inverse of y component by x component. So for F2, the y component is 20.8 minus and x component is minus 32. So the angle that F2 makes with the positive of x-axis will be theta equal to tan inverse minus 20.8. This is the x component of the vector, and x component is minus 32. Can you do the calculation for me, please? Tan এর ভ্যালু কত একটু বলবো আমাকে? 33. So that means it is making a 33-degree angle with the positive of x-axis. So এখানে একটা ছোট্ট সমস্যা, 33 degree means what? 33 means here. 33 means here. But just look at the component of F2. Is x component is also negative, y component is negative. X component, y component all are negative. That means এর x component এই দিকে কাজ করে আর y component কাজ করে কোন দিকে? Along this way. F3. হ্যাঁ, x component এদিকে আর y component এদিকে কাজ করে। তার মানে কি হবে? That means তার অ্যাঙ্গেলটা তো এইটা হওয়াটা সম্ভব না, অন্যদিকে হবে। So we know, আমরা এটা জানি যে tan theta equal to tan of 180 plus theta. এটা আমরা জানি, রাইট? এটা জানো তো তোমরা। তার মানে এটা আইদার এই যে থিটার যে 33, এই 33 বা এই যে tan theta equal to যে ay by x আমরা লিখি, হ্যাঁ, এটা equal to tan theta ও হয়, আবার tan theta plus 180 হতে পারে, বা পরেরটা আর 180 মাল্টিপল তুমি নিতে পারো, ইন্টিজার মাল্টিপল নিতে পারো। সো তাহলে theta, since এই theta 33 degree with positive x axis means that এর x component y component দুটাই পজিটিভ। তার মানে এইটা আসলে লজিক্যাল না। So we can write theta equal to 180 plus 33, which is basically 200 and কত হবে? 13, right? 213 degree. That means the direction of F3 is basically here. You see, now এটা কাজ করছে ভালোই, this way. This এটার সাথে 33 degree. This way. This is my F3. This is my direction of F3. Clear? So there are a few more math. that we're going to try. This is easy math. Let's try this easy math. Can you read this for me, please? One is a equal to a 0.34 kg object moves in a xy plane according to xt equal to 15 plus 2t minus 4t cube and y equal to 25 plus 70 minus 90 square. At t equal to 7 seconds, what are the magnitude and angle of the net force of the particle? So what I have to find out, so this is the position of an object. An object is moving in a xy plane. At xy plane, একটা object move করছে, and its x and y coordinate are given. Object is moving like this. So at every point, it has some x component and y component. This is what we know. So the x component, this is the equation for x component, and this is the equation for y component. Now, what I have to do, I have to find out the acceleration. What are the magnitude and angle of net force on the particle? Net force figure out করতে হবে. I have to find out the net force. Okay. Net force figure out করতে হবে at time t equal to 7 seconds. So net force মানেটা কি আসলে সেটা একটু দেখার চেষ্টা করি. From second law we know net force or F net equal to ma. Net force means ma. Okay, net force means ma. So that means once I can find out the acceleration, then I can easily find out the net force. Clear? So acceleration কিভাবে figure out করব? দেখো এটা 2-dimensional object, তাহলে আমরা তো এভাবে লিখতে পারি ma, that means m of acceleration has a x component I, sorry, my bad. প্রেজেন্টেশনটা বোধহয় চলে গেল। Presentation দেখতে পাচ্ছ? Is it visible to you guys?
Yes, sir.
Okay, so they're asking for the net force. So the net force is, we know the net force F net equal to basically m a, and since the object is moving in xy plane, তাহলে আমরা বলতে পারি F net is basically equal to m times axi plus ayz. Okay, this is acceleration. Acceleration equal to axi plus ayz. Ax is the x component of acceleration, ay is y component of acceleration. Okay, so this is what I have to find out now. Ax means what? আমরা জানি, we know ax is equal to d square x over dt square. Okay, ax means d square x over dt square. So my x is given here. This is d dt square of minus 15 plus 2t minus 4t cube, right? Clear? So ax will be equal to then, if you differentiate it twice, this guy will go off, this will go off, this will be 12 24t. Is it clear? Ax equal to 24t. এটা কি বুঝতে পারছো নাকি?
Yes, sir.
Okay, and same again, ay means, and ay means what? D square y, d square over dt square y, that is means d square over dt square y is 25 plus 70 minus 90 square. So ay is basically will be equal to this one 18. This would be 18 minus 18. Is it okay? So this is my ay. তাহলে we can write f net, then f net is equal to m, ax means minus 24t I plus minus 18j. This is my net force. Okay, this is my net force, and in unit vector notation you can write like again f net, m is what? 0.34 into minus 24 ti minus 18j. So this is my net for is in unit vector notation. And now what they are asking for us, তুমি চাইলে এটা করতে পারো at t equal to 7 second, t equal to 7 second কি হয় ভেক্টরটা? At t equal to 7 second, what I have to do, I have to replace just t by 7. So f net equal to 0.34 into minus 24 into 7i minus 18j. So if you just calculate this thing, you are going to get, let me do the calculation for it. .34 multiplied by 24 multiplied by 7 is equal to 57.12. Okay, 57 minus 57.12 I, and then 0.34 into 18, that is minus 6.12. Okay, so j. So this is the vector in this is the net force in unit vector notation, and once you know it, you can easily find out the magnitude now. Magnitude বের করতে পারবো না এখান থেকে, just component গুলো square root করলেই হয়ে যাবে. So let's move here. So for part A now, magnitude f net, magnitude of f net equal to square root of minus 57.12 whole square plus minus 6.12 whole square. So this is the magnitude. And angle, same again. The angle টা যেটা হবে, theta equal to tan inverse minus 6.12 divided by minus 57.12. This angle. Clear? We have few more math to, we're supposed to do few more math, but I don't have much time now. I'm going to finish it here today, and I'm going to discuss with you guys a little bit about the marks distribution. Let's turn on